Hey friends, it's Ben again. This is a video about the intermediate value theorem for Calc 1. This should be a pretty short video, okay? The essence of the intermediate value theorem is that if you have a function that is continuous, that means that between a high point and a low point, it has to take on every value in between. It's not allowed to jump because jumps are discontinuities. So if it's continuous, it's not discontinuous. Not hard, right? But let's see at least one example of it. And really the problems that you've got to work through are mostly going to be something that you can plug in a number and get an idea just from plugging in. So, all right, sharing the screen here so that you can see what I've got for pictures and stuff. All right, so this is that intermediate value theorem. Everybody always abbreviates it as the IVT, and it just says that if f of x is continuous on some interval from a to b, then for every value of c that is between f of a and f of b, then there's going to be at least one x in that interval, so that the f of x is equal to that value c. Okay, so taking a look at the graph that we've got there, make sure that you realize with regard to it, I have picked out some c value that's in between, and I've got this one place that it intersects between a and b. Now it so happens it also intersects over here outside of a to b. That doesn't have anything to do with the theorem. There might be things that happen outside the interval, but you know, they're just not part of the theorem. The other thing is I could have any value between f of a and f of b. Now notice that here, if I put my horizontal line above f of a, I still have solutions, but I wasn't guaranteed that by the theorem. Now, if you wanted to say, to heck with it, I'm going to take and scoot my value of a over there so that it's at the peak, and the value of b to be over there at the trough, then you know you get a little bit more mileage out of the theorem. But you know, how can you ahead of time pick those out? Maybe you can, maybe you can't. So the example I want us to take a look at, in the interval from 0 to 2 pi, is there a solution to 20 times the sine of x plus 3 cosine of the quantity x squared over 2, setting it equal to 2? Okay, now the point of that function is that it's miserable. As soon as you got that x squared inside of a cosine, it screws everything up, and it's just not something that you can find an actual solution for. So all we want to know is there a solution? We don't care what it is. The intermediate value theorem doesn't tell you what the solution is, just that there is one. So I'm going to pop over here to Desmos, and I went ahead of time and pointed out, or I went ahead and told it to plot the function and also to plot the y equals 2 there so you could see what was going on. Now, I'm going to, a little bit here, try to make this a less miserable experience by using some of the capabilities that's here on the app version of this. I'm going to go ahead and stretch stuff. All I did was to use 2 fingers and touched the x-axis, and then I moved things around where I wanted it. Now, since I've got stuff going up out of the screen, I'm going to use 2 fingers on the y-axis and just squish it down until I get my peaks where I want them at. Okay. So now I can look at that function there, and I can label this topmost peak, And I could label this bottommost peak. And y'all can see from the graph that at about x equals 4.711 that we've got a solution to it. Is it an exact solution? No, but it is a solution. Now, for that matter, though, instead of referring to 4.369 and 5.007, we could have used this one over here, this 1.085 and negative 13. Then we end up having three, oh gosh, I missed one, 3, 4, 5 different values of x that give us a solution to that equation. All the intermediate value theorem told us was that there would be one. And which one? Could any of them, okay? But that's what the intermediate value theorem does for us. So what I'm going to need to do is to remember that low point over there, and it's 1.085 and negative 13.466. Remember that that's approximate. And then that high point of 5.007 and 19.757. Okay. So now I'm going to jump back and I'm going to write my solution. And you know what? It would be super nice if I could draw that picture. Unfortunately, I don't have something that I can clip just part of a picture, or maybe I can. How do you do that? It's that you hit the volume and the power button at the same time, I think. That should have taken, and it didn't. Instead of taking a picture, it instead, okay. Hey Siri, would you take a screenshot, please? Yay, she did. All right. So now, yes, and I've got a low battery. So now I'm going to jump back over here, and I am going to tell it to put a picture in, and I have to hit that maybe twice, and then I can grab that. And having that in there, now I can jot down my answer just a little bit better. I'd forgotten that you could do that. There is some button to push, so you don't have to ask Siri to do everything for you, but I had to because I couldn't get the button to work. So f of 1.085 is about negative 13.5, which is less than 2. And f of 5.007 is about positive 19.8, which is greater than 2. So there is some x between, and here it's between 1 and 5, but I'm going to be just a little bit vague and say between 0 and 2 pi, so that f of x equals 2 by the intermediate value theorem. So I've provided some graphical proof. You could, instead of graphical proof, have actually, used your calculator for just some values, but you kind of got to spot the right values somehow or another. Okay, that's it. It is, or you have several problems to do like this. It's not many of them because it's all kind of the same idea. The intermediate value theorem stuff is not super hard. Okay, so go ahead and take a look at that. That's our classwork for Friday. I expect everybody to be done a little bit early. We can also spend a little bit of time then answering any questions that you might have about the exam that's coming up. Remember, the exam is on Monday, I've lost track of the dates. So yeah, check and see what the Monday is. And ask questions and be prepared for that. All right. All right. I'll talk to you later. Thanks.